Welcome students to IIT PAL problem solving session of mathematics. Our topic is probability and this is lecture number 3. In today's class, we shall solve a number of problems for which the background has already been made. So, two things or a few things that we have to remember are as follows: probability of A, where A is an event corresponding to a random experiment E, whose sample space is omega, is cardinality of A divided by cardinality of omega. And another thing that we will be using is from event algebra, that probability of A union B is equal to P A plus P B if A and B are disjoint. But if A and B are not disjoint, then probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. And thirdly, if A and B are independent events, then probability of A intersection B is equal to P A times P B. So, these are some basic things that we will have to remember, and as we shall solve problems, if we find that something new is coming, the concept is not given to you, then I shall explain that. So, let us look at the first problem. We have already seen that if x, y, z are all greater than or equal to 0 and x plus y plus z is equal to 10, then number of possible solutions is 10 plus 3 minus 1 C 3 minus 1 is equal to 12 C 2 is equal to 66. Now, what is the probability that in the above scenario x is an odd number? So, what we have to do? We know that the total number of points in omega or the cardinality of omega is 66. So, we have to find out number of cases when x is an odd number under this condition, and from there we have to compute the probability. So, solution: x can be odd implies x can take values 1, 3, 5, 7, 9. Now, consider the cases. X is equal to 1 implies y plus z is equal to 9. In how many different ways y plus z can be 9 when both y and z are greater than or equal to 0? So, the number of cases is 0, 9, 1, 8, 2, 7 up to 9, 0, that is 10. And if we understand therefore that y plus z is equal to k implies there are k plus 1 solutions, then we can easily find out x is equal to 3 implies y plus z is equal to 7. Therefore, number of solution is going to be 8. Similarly, x is equal to 5 implies y plus z is equal to 5. Therefore, number of solutions is 6. X is equal to 7 implies y plus z is equal to 3. Therefore, number of solution is 4, and in a similar way x is equal to 9 implies y plus z is equal to 1 and number of solutions is 2. Therefore, total is 10 plus 8, 18 plus 6, 24 plus 4, 28 plus 2 is equal to 30. Therefore, probability x is odd is equal to 30 upon 66 is equal to 5 upon 11. So, that is the answer. Let us consider another problem. The problem is as follows. Suppose a man is standing on the x axis at the origin. At each step he goes either to the right or to the left each with probability half. What is the probability that after 6 steps he will be at a distance 2 from the origin? So, I hope you understood the question. So, here is the initial position. So, he can go either to this direction or to this direction with probability half and half at each step. We want that after 6 steps he is here or here. What is the probability? So, how to do that? Let x be the number of steps he takes to the right direction and y be the number of steps he takes to the left direction. Therefore, x plus y is equal to 6, because we are looking at total 6 steps and modulus of x minus y is equal to 2. This is obvious. That means, either he takes 2 steps more to the right or 2 steps more to the left. Therefore, we get 2 equations. One pair of equation is x plus y is equal to 6 and x minus y is equal to 2, implies 2x is equal to 8, implies x is equal to 4, implies y is equal to 2. And second set of equation is that x plus y is equal to 6, y minus x is equal to 2, implies 2y is equal to 8, implies y is equal to 4, implies x is equal to 2. So, this probability is 0.5 whole to the power 6. Similarly, this also has probability 0.5 whole to the power 6. Therefore, desired probability is equal to 2 times 0.5 to the power 6 is equal to 0.5 whole to the power 5. So, that is the answer. Let us now consider another problem. Suppose A, B, C are 3 events corresponding to a random experiment E such that 1 probability of A union B union C is equal to 1. 2. A, B and C are equally likely. 3 A intersection B, B intersection C and A intersection C are also equally likely. 4. Probability of A intersection B is equal to probability of A divided by 2, and probability of A intersection B intersection C is equal to probability of A intersection B divided by 2. Find the probability of A intersection B intersection C complement. That is the problem. Now, before I start solving, let me explain to you that A union B union C is equal to 1. That means they cover the entire sample space, but it is not that they are disjoint. That is, A intersection B, B intersection C and A intersection C, they can be with positive probability. And what do you mean by equally likely? It means that all the 3 events have the same probability. Similarly, A, B, C are equally likely, A intersection B, B intersection C and A intersection C are also equally likely, and moreover probability of A intersection B is half of probability of A. We need to find out the probability of A intersection B intersection C complement. So, we move as follows. Let probability of A be equal to x. Therefore, probability of B is equal to probability of C is equal to x. Therefore, probability of A intersection B is equal to probability of A by 2 is equal to x by 2, and that is same as probability of B intersection C and probability of A intersection C, and probability of A intersection B intersection C is equal to half of that, therefore, x by 4. Therefore, probability of A union B union C is equal to, we know that it is probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersected with A plus probability of A intersection B intersection C. Now, it is given that this is 1. This implies that 1 is equal to 3 times x, these are all x, plus this is x by 4 minus 3 times this and this, these are all x by 2, implies 4 is equal to 12x plus x minus 6x is equal to 7x. Therefore, x is equal to 4 by 7. Therefore, probability of A intersection with B intersection with C complement is equal to probability A intersected with B minus probability of A intersected with B intersected with C is equal to x by 2 minus x by 4 is equal to 2 by 7 minus 1 by 7 is equal to 1 by 7. So, that is the answer. Now, let us solve another problem. Suppose a pair of dice is rolled. The dice is fair, that is probability of 1 is equal to probability of 2 is equal to probability of 6 is equal to 1 by 6. What is the probability that the sum is 8 or you get even numbers on both the dice. So, that is the question. Answer: let A be the event that the sum of the two faces is 8. Therefore, possible combinations are 2, 6, 3, 5, 4, 4, 5, 3 and 6, 2, that is 5. Therefore, probability of A is equal to 5 upon 36, since there are 36 points or 36 pair of points in omega. Let B be the event that the face on both the dice is even. Therefore, possibilities is it can be 2 2, 2 4, 2 6, 4 2, 4 4, 4 6 and 6 2, 6 4, 6 6, that is 9. Therefore, probability of B is equal to 9 upon 36. Therefore, probability of A union B or both of them are even is equal to probability of A plus probability of B minus probability of A intersection B. Now, what is the probability of A intersection B? That means both the faces are even and the sum is 8. So, we can see that this is one way, this is one way and this is one way. So, there are 3 such cases when the sum is 8 and both of them are even. Therefore, this probability is 3 upon 36. Therefore, the answer is 5 by 36 plus 9 by 36 minus 3 by 36 is equal to 11 upon 36. So, that is the answer. So, let me do another problem. Suppose A and B are playing the final of a tournament against each other. The final may be best of 3 matches or best of 5 matches. The probability that A wins a match against B is 0.4, but A has the advantage that he can choose whether it will be best of 3 or best of 5. Which one will A choose? So, that is the question. Answer: obviously, A will choose the format where he has more chance of winning. So, let us compute the probabilities. That A will win the tournament for both the options. So, let us first consider best of 3 scenario. Here, or the player who wins 2 matches first is the winner. Therefore, A can win if 1. He wins both first and second match, or he wins one of first and second match and then wins the third match. So, this is an either or. In one of the situations, he is going to win the tournament. Therefore, probability A wins the tournament if the outcome of first 2 matches are win, win, or it is the first 2 are win, loss, and then he wins the third match, or the first 2 are he loses, then he wins, and then he wins the third match. So, these are the 3 disjoint scenarios when A wins the tournament. So, this probability is 0.4 multiplied by 0.4. Here it is 0.4, 0.6 and 0.4, and here it is 0.6, 0.4 and 0.4. Therefore, this probability is 0.4 whole square plus 0.4 whole square multiplied by 0.6 plus again from here 0.4 whole square multiplied by 0.6 is equal to 0.4 whole square into 1 plus 0.6 plus 0.6 is equal to 0.16 multiplied by 2.2 is equal to 0.352. Let us now consider best of 5 scenario. The final can be over with A winning in the following ways. One, A wins the first 3 matches, which has probability 0.4 whole cube, to A wins 2 of the first 3 matches and then wins the 4th match. Its probability is 0.4 whole cube multiplied by 3 into 0.6, because in the first 3 there are 3 possible ways that A wins 2 matches, which are WWL, WLW and LWW. Each one of them is going to give you 0.4 whole square multiplied by 0.6, and this will be followed by a win by A, which is 0.4. Therefore, this is the probability of this happening. In a similar way, the other way that A can win is that A wins 2 of the first 4 matches and then wins the 5th one. Therefore, out of the first 4, he wins 2. This can be done in 4C 2 ways. Say for example, win, win, loss, loss, win, loss, win, loss, win, loss, loss, win, loss, win, win, loss, loss, win, loss, win, loss, loss, win, win. And then he wins the 5th match. Therefore, the probability is 6 into 0.4 whole square into 0.6 whole square into 0.4 is equal to 0.4 whole cube multiplied by 6 into 0.6 whole square. Therefore, probability A wins the tournament is equal to 0.4 whole cube plus 3 into 0.4 whole cube into 0.6 plus 6 into 0.6 whole square into 0.4 whole cube is equal to 0.4 whole cube multiplied by 1 plus 1.83 3 into 0.6 plus this is 0.36. So, 2.16, which is close to 0.317, that you can compute. Therefore, A should choose best of 3 option. Because this is less than 0.352. Another problem. Suppose 5 candidates A, B, C, D and E are waiting to appear in an interview. It is known that the board or the interview board will call them randomly in any order. Find the probability that A is called before B. Find the probability that A comes before B and B is called before C. Third is, find the probability that B is called just after A. So, this is one paragraph. Based on that, we are given 3 different questions and we need to find solutions. A is called before B. So, there are many possibilities. A is called at number 1. Therefore, in the remaining 4 positions, whenever B comes after A, therefore, number of possibilities is equal to factorial 4, because A comes here and in these 4 positions the remaining 4 candidates can come in any order. A is called at number 2. Therefore, B has to come in one of these positions. Therefore, out of C, D, E, one is chosen and put here. That can be done in 3 ways, and now the other 2 and B can be permuted here in factorial 3 ways. Therefore, number of possibilities is equal to 3 into factorial 3. Third is that A may be called at number 3. Therefore, B can be in one of these positions. Out of the other 3, you choose 2 and put them there. That can be done in 3 ways, and then they can be permuted among themselves. So, that can be done in 2 ways. Now, B and the other candidate can be permuted here in 2 ways. Therefore, total possibilities is equal to 12. A is called at number 4. Therefore, B has to be here, and other 3 can be permuted here in factorial 3 is equal to 6 ways. Therefore, number of possibilities is equal to factorial 4, which is 24, plus 3 into factorial 3, which is 18, plus 12 plus 6 is equal to 60. Now, total number of permutations of 5 numbers is factorial 5 is equal to 120. Therefore, probability A is called before B is equal to 60 upon 120 is equal to half. Now, if you are smart enough, you can get this answer even without computing anything, because the whole scenario is symmetric between A and B. Therefore, half chance or probability is half that A will be called before B, and similarly probability is half that B will be called before A. So, I could have got the answer right at the beginning, but I computed it for you to see that you arrive at the right answer, and also I demonstrate before you how to solve this type of problems. Now, B part is A before B and B before C. In how many ways it can be done? So, suppose A is in position 1. Now, B and C have to be arranged in such a way that B is before C. So, if B is in second position, then there are 6 possible ways of arranging them. If B is in third position, then out of D and D, you put 1 in the second position. That can be done in 2 ways. Then you put B here, and C can be in this. That can be done again in 2 ways. Therefore, there are 4 possibilities. B is in fourth position. Therefore, C has only one option of coming in the fifth position. Therefore, out of the remaining 2, you can arrange them in this in 2 ways. Therefore, there are 2 possibilities. Implies 12 possibilities. A is in position 2. Therefore, how many possibilities are there? B is in third position. Therefore, out of D and D, you can choose 1 in first position. That can be done in 2 ways, and C and the other one can be permuted here in 2 ways. So, there are 4 ways of doing that one. B is in fourth position, and that also can be done in 2 ways. Therefore, total number of possibilities is 6. A is in third position. Therefore, D and D are in first and second position, and that can be done in 2 ways, and obviously A cannot go to fourth position because B and C will have to come after him. Therefore, total possibilities is equal to 12 plus 6 plus 2 is equal to 20. Therefore, probability A comes before B and B before C is equal to 20 upon 120 is equal to 1 by 6. A comes just before B. Therefore, what we can do? We can keep AB as 1 unit, and therefore, we have now AB, C, D, E, and they can be arranged in factorial 4 is equal to 24 ways. Therefore, probability is equal to 24 upon 120 is equal to 1 upon 5. Answer. Another problem. Suppose 5 persons A, B, C, D and E are sitting in a circular table. You have hats of 3 colors: white, red and green. In how many ways you can give one hat to each person such that no two consecutive persons have hat of same color. So, this type of problems can be solved by drawing a tree. So, we have A, B, C, D and E. Note that A and D are side by side because it is a circular table. Suppose you give the white color cap to A, then B should get either red or green, because they cannot have same color because they are sitting next to each other. Now, B is red, therefore, C can get white and green, and similarly, when B is green, C can get white and red. Therefore, D can get red and green or red and white or green and red and green or white. Now, at this position, therefore, we have 8 different possibilities. Now, since D is red, E can get white and green, but E cannot get white because A has white. Therefore, in this case only green. If it is green, then in this case it can be only red. If it is red, then again it can be only green, but if it is white, then it can get both green and red. Similarly, this is red, this is green, this is red and this is green or red. Therefore, total possibilities are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This 10 has come when A got white, but A can get white, green and red. Therefore, total possibilities is equal to 10 into 3 is equal to 30. So, before I stop, I do one more problem. Suppose 2 teams Mohunbagan and East Bengal are facing each other in 2 matches. For each match, the winner gets 3 points and loser gets 1 point. For a drawn match, both the teams get 1 point each. If Mohunbagan has 0.5 probability of winning, 0.1 probability of drawing, and 0.4 probability of losing, what is the probability that Mohunbagan ends with more points than East Bengal? So, that is the question. So, again we start from using a tree. So, 0.5 is the probability that Mohunbagan gets 3 and East Bengal gets 0. 0.1 is the probability that both of them get 1, and 0.4 is the probability that Mohunbagan gets 0 and East Bengal gets 3. This is about the first match. In the second match, 0.5 probability that Mohunbagan wins. So, Mohunbagan's point is 6, East Bengal's is 0. 0.1 that they draw the match. So, the final tally is 4, 1, and 0.4 is that Mohunbagan lose. Therefore, this is going to be 3, 3. From 1, 1 with 0.5, it is going to be 4, 1. With 0.1, it is going to be 2, 2. And with 0.4, it is going to be 1, 4. From 0, 3 with 0.5, it is going to be 3, 3. With 0.1, it is going to be 1, 4, and with 0.4, it is going to be 0, 6. Therefore, probability Mohunbagan point is greater than point of East Bengal is equal to 0.5 into 0.5, because that is the probability along this branch. This is 4 1, therefore, it is 0.5 into 0.1 plus this is 4 1, therefore, 0.5 into 0.1 is equal to 0.25 plus 0.05 plus 0.05 is equal to 0.25 plus 0.1 is equal to 0.35. Instead, if we asked what is the probability that they end up with same point, then what you would do? You will look at the situations when they have the same points. So, this is 3 3, which is 0.2 plus this is 2 2, which is 0.01, and this is 3 3, which is 0.2 is equal to 0.41. Therefore, it is obvious that probability Mohun will have less point than East Bengal. You can easily understand that these two together is 0.76. Therefore, this is going to be 0.24. Okay, students, I hope you understood how to compute the probabilities using a tree diagram and also using the independence of these two events, because these are two matches whose outcomes are independent of each other, and that is why we have used the multiplication, and since these are disjoint events, therefore, we have made use of addition, and like that we come to the final probability. Okay, friends, I stop here today. In the next class, I shall work out some more interesting problems for you. Okay then, thank you.